Hey guys, welcome to question FM321 of the Further Maths Fortify study guide. This question reads, two similar cylinders are produced by a manufacturing company. The larger cylinder has a base area of 22.7 square centimeters and a height of 40 centimeters. The scale factor is 3. Then we're shown just a little diagram with two cylinders. We're then asked, the formula of the smaller cylinder in cubic centimeters can be found using the formula, and then we're given 5 options. So the way that we're going to look at this question is first, what we're being asked to do is find the volume of our smaller cylinder, okay? So the volume of our smaller cylinder could be found using the volume of our bigger cylinder, and multiplying that with some version of our scale factor. Okay, so breaking this question down a little bit, we're going to start with the volume of the big cylinder. So of course we can find the volume of any prism or cylinder, that kind of thing, by finding the base area or the area of the face, and then multiplying that by its height. So to find the volume of the larger cylinder, we're going to take its base area of 22/7 square centimeters and multiply that by its height of 40 centimeters. Now we're not actually going to complete the rest of this calculation, because if we look through our options, we can see that pretty much all of them use some version of 22/7 times 40. So it's a fair guess to say that that's how we're going to be representing the area of our, the volume of our larger cylinder in our answer. So once we've done this, the next thing we want to take on is our scaling factor. So we've been told that our scale factor between the two cylinders is 3. So we've been told that K is equal to 3. Now, if K is equal to 3, it means we could also use it as 1/3, use the inverse in order to scale down. So if we're scaling up, obviously multiplying something by 3 is going to scale it up, and multiplying it by 1/3, a number that's less than 1, is going to scale it down. So since we're going from a larger cylinder to a smaller cylinder, we're going to be using this 1/3 to scale down. Now, the other thing to think about here is also that K, or our scaling factors as they're given to us when it's just like this, is one-dimensional. So this 1/3 and this 3 applies when we're trying to change one-dimensional lengths. So if I was only looking for the radius, how the radius changes between these two cylinders, I would use this 1/3 or 3 if I was going up. However, we're looking to change or look at the volume. So if we're going to scale using the volume, we need to use K cubed. So K cubed, since we're scaling down, is going to mean that we're using a 1/3 to the power of 3, or a 1/3 cubed. Whacking this all together back into this formula that we had originally, so we've got our volume of our smaller cylinder. It's going to be equal to the volume of our larger cylinder times by our scaling factor, or a slightly revised one, like this. Looking at our potential answers out of the 5, we can see that D looks very similar to this, it's just in a different order, and of course D is our correct answer. If you guys have any questions for us about any of this, please leave them in the comments below. Otherwise, I'll see you in the next video.